Here's what's coming today on the Woodworking Network podcast.
Right, this entire finish, this is on MDF. The entire finish was done in 7 minutes from hanging it on the line to exiting the oven.
Welcome to this episode of the Woodworking Network podcast. Join us as we explore the business of woodworking, big and small, and what it takes to succeed. I'm Will Sampson. Today's episode is sponsored by the Executive Briefing Conference. We'll be talking with Chris Redding, Global Director for Alternative Substrates for IFS Coatings, to fill us in on how powder coating is making inroads in the woodworking industry. But first, I want to talk about, it's called a finish for a reason. One of the most fascinating things about woodworking is how crucial the final finish is to the success of a project. But workers, by and large, devote more energy to the woodwork than they do to the finish. It's always been my theory that woodworkers are mostly mechanical in their approach to their work. They're all about physically manipulating the wood, cutting and shaping and joining and fitting to get a sturdy and handsome result. Then comes the finish. It's almost an afterthought. In the hobby world, far too many projects just get a wipe of oil or a splash of poly, and the maker calls it good. Complex finishing processes are just that, complex. And they take the woodworking mechanic into the realm of chemistry, a place an awful lot of woodworkers seem uncomfortable. In the professional world, virtually everyone recognizes the importance of a finish and the perceived value of a project. The final finish is what the customer sees and touches. It doesn't matter if the piece has the best woodworkmanship in the world if it has an unsatisfactory finish. And if it has a spectacular finish, the customer will pay more and be very happy. That's why professional shops value talented finishers. A good finisher is like that magic medieval alchemist who could mix up a secret potion that turns lead into gold. Only the finisher is turning woodwork into gold for the shop. I readily confess that I come from the mechanical woodwork side. I have high admiration for great finishers. They always seem a bit eccentric to me, but that's okay because they deliver the goods. I know I can't compete with their talent. My own finishing experience is long and varied. When I started woodworking in grade school, it was all about paint. I think my first woodworking project was a helicopter I sawed out of a couple of boards and nailed together. It got a sloppy blue tempera paint finish that was good enough for a 6-year-old. When I really started getting into woodworking, I learned about stains and oil-rubbed finishes and various varnishes, including the ubiquitous polyurethane that was a new thing when I first tried it. When I got interested in making stringed musical instruments, I learned how to spray nitrocellulose lacquer and then sand and polish many coats to get that glassy gloss that looked so good on a guitar or mandolin. I should digress a bit here to describe my real spray finish education that had nothing to do with woodworking. In a previous life, I built custom bicycle frames and finished them with DuPont Imron, a catalyzed polyurethane that had all sorts of nasty stuff in it, like ether and isocyanates. I had a full spray booth, separate air line for breathing, and I learned how to spray vertical tubes in tight quarters without runs. Talk about chemistry. I had to learn about reducers and precision mixing and Zan cups and fisheye treatments. I learned new technical terms like sheen, orange peel, and force drying. But I'm still not a chemist. I've visited finish manufacturing and testing labs and toured countless finishing operations, including highly automated processes. I am amazed by the technology, but my interest is in just getting a guaranteed good result to complete a project. After all, that's why they call it a finish, isn't it? I guess I'm more like the cook that needs to follow a recipe rather than the chef who can take a handful of desperate ingredients to create something spectacular. Before we get to our interview with Chris Redding, let's pause for a word from our sponsor. EBC is a superior opportunity to learn, be inspired, and have face-to-face interchanges with top leaders in the woodworking industry. The 2021 EBC will be held September 8th through 10th at the spectacular Broadmoor in Colorado Springs. In addition to top speakers and presentations, there will be tours of Concepts in Millwork and the Mill Woodworking Training Facility. It's an unparalleled opportunity to obtain business intelligence to improve your enterprise while networking with the industry's brightest stars. You can learn more at executivebriefingconference.com. Today we are pleased to have as our guest Chris Redding, Global Director for Alternative Substrates for IFS Coatings, to fill us in on how powder coating is making inroads in the woodworking industry. Welcome to the Woodworking Network podcast, Chris.
Thanks, Will. Glad to be here. Appreciate that.
Now, can you give us a little information on your background in finishing? A global director for alternative substrates sounds pretty impressive, but what does that really mean?
Yeah, well, I mean, the title means basically anything that has to do with powder coatings on something other than metal, right? So we call those alternative substrates. I'm sure they don't think of themselves as alternative, but yeah. So if it's powder on non-metal, it's under it's my responsibility within IFS Coatings. Yeah, I've been in powder since 1996. Whenever I got out of the military, started off in the operations role in a little company called Courtaulds Coatings, and from there have had responsibility to make paint, to do all the quality assurance stuff, basically all the roles within a powder coating manufacturing operation, and finally into powder coating sales, and then transitioned later to raw materials and binder systems, and that's where I've spent the last 10 years before, well, actually more like the last 15 years before I came to IFS, and I came to IFS like 2 years ago. So yeah, I've pretty much done nothing but coatings since the military, and so that's in all sorts of roles under that umbrella. Well, then you have a real good handle then on what kinds of applications in woodworking are particularly appropriate for powder coating. What does it work on? Well, if I look at where we really, the culmination of technologies kind of came together and made this type of application truly robust for the first time was really in Europe. And the successes there, the early adopter community were largely cabinet manufacturers, doing cabinet fronts with powder, but also ready to assemble furniture has done quite well there. There's without naming the company that anybody can guess, the biggest RTA manufacturer on the planet adopted powder for bathroom vanities and for day beds, and they're tugging out about 9,000 units a day at their plant in Slovakia. So it sounds like it's for areas that are in high use, possibly areas that have moisture and that sort of thing. Is that? Yeah, and the throughput advantages are amazing, right? And so any type of big scale operation, it's certainly a nice draw. But we also, have a space there and are able to equip small players who may want to paint, 2 or 3 kitchens a week, right? So this is the type of thing we can do. I think the difference is, and I know we're not on video, but I'll show you just because it helps me to talk through it, right? So here's a cabinet front done in a sort of a low gloss white, right? This entire finish, this is on MDF. The entire finish was done in 7 minutes from hanging it on the line to exiting the oven. And so that has been a great space for it. I think maybe we should stop there just a minute and back up a little bit. Can you go through what's the process of how powder coating on wood works? What's sure about that compared to, some people may be more familiar with it on metal, but yeah. What's the basic process of how it works? Well, the powder is, in this case, electrostatically applied, right? So we have a gun called a Corona gun that pneumatically conveys the powder through hoses from a hopper. As it exits this gun, it goes through a Corona field, which is a big charge of negative ions, right? And the powder picks up that charge. And then we use the moisture content of the wood as a conductive means to ground it. So that charged powder is then electrostatically drawn to that grounded workpiece. And this is the way of application. Now, right before that, typically with engineered wood, because we want to equalize that moisture content so the ground is even throughout the board, we'll preheat it to, in most cases, about 120 degrees Fahrenheit at the point of powder application. That's not because we need the heat to apply it, it's because we want to even out the ground.
I find so that means that it'll coat evenly that way with.
Yeah, and I find with hardwoods,
electrical charge throughout.
Right. With hardwoods, it typically isn't necessary to do the preheating. For some reason, their moisture content is already more equally distributed than what we find in engineered woods.
That's
anyway, I should have thrown that at the beginning. We finished that. We electrostatically applied after the preheat. Then we'll enter an oven where we'll spend, this is an IR oven, and we'll spend about a minute in preheat or ramp up actually from its temperature to about 265 F. And we'll hold it at that temperature for 3 or 4 minutes. And then we're cured and we're done.
So basically the heat melts the powder so it becomes a homogeneous coating on the surface.
It's homogeneous when you get there. I mean, our solvent or diluent and powder is air, right? So we just use the air to get it to as a medium to get it there where it's going. And then we have 100% solids, right? Where we'll melt and flow in the initial stage. And then when we hit the cure temperature, there'll be all the cross-linking and it happens really quickly, quickly. But because one of the developments in chemistry allow us to segregate flow from cure, we can spend time just getting that surface smooth before we start cross-linking. And so I would say we're not as smooth as like the smoothest liquid finish, but we can do something that is smoother than what you see with like thermal flow.
Interesting. So you're not going to get a ultra high gloss, but you're going to get a semi-gloss kind of a
well, we can do very high gloss finishes. The thing is with the higher the gloss, the more you see that surface topography come out, right? And so you could start to see that it's not quite as smooth. Now, in a low gloss finish like this, the white, which you see in about a third of the cabinets that are out there now, right? That low gloss, we're not able to see that orange peel is what we call it, right?
Uh-huh,
the more you raise the gloss, the more you're going to see that.
Mm-hmm.
But one thing that can be done pretty effectively if you want that full gloss, like European look, is it going to buff it out, right? Or we can go with a clear top coat, right? So when I think about one of the biggest areas for the initial growth that I see and where I've got, a very large brand new custom coater in North Texas is they're launching with a powder primer. So I've got one of those, right? So here's a board with powder primer, right? And it was applied just the same way that I described for the white board. Now we formulated the product to make it easily sandable, but still have a lot of good surface performance. So if you can, very deep routings, we're able to fill those, and when they're sanded, they get very flat. The real magic happens here whenever you take to a liquid finisher who's doing multiple coats to achieve opacity, right? Oftentimes, well, with a powder primer, we've completely sealed that board. And so it doesn't soak up any more paint, and you can get opacity with one coat. So just as a test last week with my customer in their facility, I got a can of safety yellow, which is about as tough a scenario as I can think of to get opacity. and we put it on the primer in one coat. It was completely done.
Wow,
So,
that's great.
so there's an opportunity where if we demand that liquid finish, right, we can still help a lot in terms of speeding up your process, reducing layers, helping you with your environmental footprint.
Now, are there any complications? You're saying you have to get up to 265 degrees Fahrenheit to melt the powder.
Yeah.
Are there any complications in woodworking with that kind of a temperature versus adhesive?
I find our stopping point seems to be needlewoods, where like pine,
so like pine and fir and that sort of thing.
Such a high sap content. Yeah, and we struggled there, but because probably one of the important breakthroughs I should mention was the IR oven, the catalytic IR oven. It's really helps us a lot with wood. It was a big breakthrough, and I can't overstate how important it was. That it turns out there's a wavelength in the IR spectra, which is sort of the high end of the medium wavelength between.
And IR is infrared for folks.
Yes, sir. Yeah. So between that 4 and 5 micron space, organic materials like powder coatings love to absorb the energy. Right. So if you look at a spectrophotometry reading of a powder coating, everywhere but that 3 to 4 micron range, the powder is doing nothing with that heat. It's just waiting for the board or the substrate to heat up so it can take the heat from that. But with IR, at that wavelength, it absorbs the energy. And so I don't care what the substrate temperature is. I don't have to heat the substrate. I can cure the powder without heating up the substrate.
Interesting.
And it makes all the difference in the world. And also with IR, with infrared, whatever your dwell time was before, you can cut it by 2/3. So that's why I'm in and out of that oven so quickly.
That's great. But now, are there any applications that are really not appropriate for powder coating? I mean,
every time I think we've figured out everywhere we can go, a contract coder somewhere figures out somewhere new. I have some friends I've been working with for years in New Zealand. They're actually putting powder paint on drywall for modular houses.
Wow. How do they do the infrared there? Is it all with like?
It's I mean, they're putting it through that IR oven on there's a horizontal configuration and a vertical configuration, but it's a little bit more of a trick on the electrostatics to make it work, but they make it work and it looks great. And it's growing like crazy. And then believe it or not, they're doing plywood for cladding as an alternative to house wrap.
Oh, wow.
And they can't make enough of it.
That's very interesting.
So it just, like I said, on woods, I've discovered, needlewoods are not there, but I have a contract coder out west, and he was getting started on MDF, and he comes out and he's got fiberglass gun stocks, and he's powder coating those, right? And so, there's nothing like the creativity of these contract coders to figure out new places we can go. There's a guy out west doing perfume bottles. Glass perfume bottles with powder paint.
That's it for today. We'll have more from Chris Redding about the amazing advances in powder coating on wood in our next episode. If you're looking for more of our podcasts, you can find all of them at woodworkingnetwork.com/podcasts and in popular podcast channels. Be sure to subscribe so you don't miss a single episode. Thanks again to today's sponsor, the Executive Briefing Conference. If you have a comment or topic you'd like us to explore, contact me at will.sampson@woodworkingnetwork.com. Thanks for listening.